So good morning. Today class we're discussing about design thinking based we have to approach in mechatronics. Okay. So we have last class we discussed about what is the meaning of mechatronics, what is the meaning of system and models approach. We have taken n number of terminology we have to study new topic of mechatronics. Okay. So after we now going to move for the next topic was is called as a static performance. Not only static performance, it is called as a performance terminology for the transducers. Okay, so first of all, the mechatronics is nothing but is a combination of the wide field is like the electrical, mechanical, and computer science. So its main objective is to product the system. That is very important. And also the transducer's main importance, the physical quality is converted as an electrical signal, and also is all it converted as an actuators. Okay, like an example, physical quantities called as force, torque, something. These are etc. Okay, now we can go for the static performance. Mr. Nishant, they have to explain the what are the static performance and what are the points we have to take in the individual students we have to discuss in now. Yes.
Myself, Nishant. I am from third year Mechatronics. I'm going to explain the three important terms used in transducers: range, span, and error. Let's talk about range. The range of a transducer refers to the maximum and minimum value it can measure. For example, if a pressure sensor can measure from 0 to 100 psi, then its ranges is 0 to 100 psi. This tells us the total working limit of the device. Next, we go for span. Span is simply the difference between the maximum and minimum value of the range. So, for our pressure sensor with range 0 to 100 psi, the span would be 100 psi. The span helps us to understand the active measuring portion of the transducer. Next, we come for error. Error is the difference between the actual value and the measured value. It indicates how accurate the transducer is. Errors can cause many devices to misfunction, like due to many factors like temperature change and poor calibration or environmental interface. For example, if the actual pressure is 50 psi, the transducer reads 52 psi. The error is plus 2 psi. So next, Sarvesh will talk about it.
My name is Sarvesh, third year Mechatronics. So the next three physical static characteristics I'm going to talk about is accuracy, precision, and sensitivity. So first, accuracy. Accuracy may be defined as the ability of a machine to respond to the true value of a measured variable. It is under the reference condition which we are giving. So it also refers to how closely the measured value agrees to the true value. So next is precision. So precision, it can be defined as the ability of a machine to give a degree of exactness under same conditions for a short interval of time. It can also be defined as the ability of an instrument to respond to a group of measurements of the same measured quantity under the same condition. So next is sensitivity. Sensitivity of an instrument can be defined as the ratio of the output signal and to the ratio of input signal. So if there is a small change in sensitivity, we can define sensitivity as interdecimal change of output signal to the ratio of interdecimal change to the input signal. So if the input and output relation is linear, then the sensitivity will be constant for all the values. So if the sensitivity curve is non-linear, then the static characteristics of the sensitivity of the instrument depends on the value of input quantity.
So hi, I'm T. Srinidhi from third year MCT. I'm going to talk about hysteresis. Hysteresis defines the difference in output for a given input. Why this value is approached from the opposite direction. The phenomenon occurs while mechanical, electrical, physical and chemical processes. And the next topic is repeatability. Repeatability means defined by the closeness of agreement among the number of consecutive measurements of the outputs of the same value. Then reproducibility. It defined as the closeness of agreement among the repeated measurements for the output of the same value under the same operating conditions. And the next topic is readability. Readability defined as the closeness in which the scale of an analog instrument can be read. Resolution. It is the smallest change in the measuring variable to which an instrument will be responding. Dead zone. Dead zone is the largest range of values, measured variables, to begin its response for a change in a measured quantity called dead time. Backlash. Last motion of free play of the mechanical elements such as gears and linkage.
Hi, I'm R. Ananya of third year MCT. Bias, the constant error which exists over full range of measurement of an instrument is known as bias. Tolerance, it is the maximum allowable error in the measurement. Drift, the variation of change in output for a given input over a period of time is known as drift.
Here we know about dynamic characteristics. I am Tarika from third year MCT. In many practical cases, the parameters to be measured are time varying. For example, in dynamic nature, those the input and output measurement is also time varying. The behavior of instrument under such time varying